Okay, so now that we know what binary numbers are, we are going to learn how to convert from binary to decimal and from decimal to binary. So let's start with a decimal numbers and how we can think of this. Let's start with the number 342. Now, in decimal, we call this the units position. This is the tenths position, and this is the hundredths position. Now, what's another way to write 342? We can write 300 plus 40 plus 2, correct? And actually, another way we can also write this is 3 times 10 to the power 2 plus 4 times 10 to the power 1 plus 2 times 10 to the power 0. Because anything to the power 0 is 1, and this would just be 2. And then 10 to the 1 is just 10. This is going to be 40. This is going to be 300. Right? So we actually do something similar in binary, but we can do this. We can do something to convert from binary to decimal. So let's say we had the binary number 1, 1, 1, 1. We actually know that this is 16. But let's try to convert it anyway. Now, this is like in the decimal system. We're going to call this the 0th position, our first position, our second, and our third. Now, in our 0th position, we have 1 times 2 to the power 0, plus in our first position, we have a 1, so it's going to be 1 times 2 to the power 1, plus 1 times 2 to the power 2, plus 1 times 2 to the power 3. Now, this is going to be 1, because 2 to the power 0 is 1, and 1 times 1 is 1, plus 1 times 2 to the power 1, that's going to be 2. 2 to the power 2 is 4, 4 times 1 is 4. 2 to the power 3 is 8, 8 times 1 is 8. And when we add this up, 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. I'm sorry, that's actually 15 in binary. If you look at a chart online or something, 16 is actually 1, 0, 0, 0, 0. This is actually 15 in binary. Okay, now let's do a different number where we have zeros thrown into the mix. Let's say we had the number 1101. Okay? Well, let's start from our 0th position. We have a 1, so this is going to be 1 times 2. This is going to be 1 times 2 to the power 0. Plus, we have a 0 in our first position, so this is going to be 0 times 2 to the power 1. And in our second position, we have a 1, so this is going to be 1 times 2 to the power 2, plus 1 times 2 to the power 3. Okay? Now we can cross this out because it's just going to be 0. 0 times 2 to the power 1 is 0. 2 to the power 0 is 1. 1 times 1 is 1. So this is going to be 1 plus 2 to the power 2 is 4. 4 times 1 is 4. 2 to the power 3 is 8. 8 times 1 is 8. So 8 plus 4 is 12. 12 plus 1 is 13. So 1101 is 13 in binary. Let's try to count to see if we're right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, now let's try to convert with more than 1 0. Let's say we have 1 1 0 0 1 0 0, just to make it a little complicated. So this is our 0th position, so it's going to be 0 times 2 to the power 0. This is our first position, so it's going to be 0 because we have a 0 times 2 to the power. This is our first position, so this is to the power 1 plus, and then we have a 1 here in our second position, so 1 times 2 to the 2 plus 0 times 2 to the third plus 0 times 2 to the fourth plus 1 times 2 to the fifth plus 1 times 2 to the sixth. And if you actually memorize your powers of 2, this can go pretty easy. So this is going to be 0. We don't care about it. 0, 0, 0. We only care about these. This is 4 times 1. This is 4. 2 times 5. This is 16 times 2. This is 32. And this is 64. So we have 4 plus 32 plus 64. 64 plus 32, that's 96. 96 plus 4 is 100. And let's actually use an online converter. We're actually right. It is 100. Okay, now let's go the other way and convert from decimal to binary. Let's say we have the number 26. How would you convert that to binary? Well, first let's divide by 2. This is an even number, so it's 26 divided 2 is obviously 13. We don't have any remainders because it's an even number. We're not going to get any remainders. Then we take the number 13 and divide that by 2. What's 13 divided 2? Well, 13 is not an even number. So let's subtract 1 from 13. It's going to be 12. What's 12 divided 2? Well, 12 divided 2 is 6. But remember, our number is actually 13, not 12. So we have a remainder. It's going to be 1. Now, let's take that number and divide that by 2. Now, 6 is an even number. 6 divided 2 is 3. We don't have any remainders because 6 is actually an even number. It divides perfectly by 2. Okay, now let's take that number and divide it by 2. 13 divided 2 is, well, 30 is an odd number. So let's subtract 1. 2 divided 2 is 1. But our number is not 2, it's 3. So we have a remainder. Our remainder is 1. Now let's take that number and divide it by 2. Now 1 is not an even number. So subtract 1. 0 divided 2 is 0. But our number is not 0. So we have a remainder and it's 1. Now when we write it down, we start with this as our most significant bit. So we write down this one, and then this, and then this, and then this, and then this. So 26 in base 10 is equal to 11010 in base 2, or binary. And we actually use this to signify what base we're in. Depending on which class you're in, your professor might require to write this. It shows what base you're in, basically. Sometimes you actually have to write the parentheses. It depends. But let's use an online converter now to see if we're actually right. So our number was 26. And we have 11010. And we're right. It's 11010. So this is how you convert from decimal to binary. And from binary to decimal. Thanks for watching.